Now we're at lesson 11B. In the next preview assignment and in the next class, you'll need to be able to calculate absolute change and relative change, but not unless we can read them. There we go. Absolute change and relative change, as well as understand the parts of a formula. We're going to start with the absolute change and relative change. These are ideas that we've talked about throughout the semester, but they will be recurring in this class and in your 1332 class. It does mention in Worksheet 7D you did compare them for CD sales. You learned that absolute change is, if you don't already have this written down, it is the difference between a final value and an initial value. Relative change is a ratio. It's a ratio of the absolute change, probably from above. Probably you'll just reuse the calculation you already have, and the initial value in the denominator. And we usually write it as a percentage. So now's the time for you to hit pause. Go ahead and answer question 1, and then come back and we'll look at this and more together. Question 1 states that the cost of a Dr. Pepper in 1880 was 5 cents. The cost of a Dr. Pepper in 2018 at a grocery store in Kingwood, Texas is $1.89. What's the absolute change in the cost? This says we're going to take, it's a difference between the initial value and the final value. Another way to look at it could be the ending number and the beginning number. Whatever way makes sense to you, the number we are most recently looking at is $1.89. The number from a long time or before it is 5 cents. And so when we go to find their difference, the absolute change is $1.84. To calculate the relative change, you can simply take your value for the absolute change, write it as a ratio, as it says right here, of the absolute change in the initial value, the starting value. And in this scenario, we were talking about in 1880, we started with a Dr. Pepper being 5 cents. And we're going to write it as a percentage, and we need to go ahead and divide before that. So $1.84 divided by 0.05, I get a decimal value, but to write it as a percentage, we need to write it as 3,680%. I think the price has increased a bit. So still looking at absolute change and relative change, our preview 11B is going to have new notation, delta notation. Means it has a delta, a Greek delta, meaning change in. And we're going to connect this to the absolute change and express the relative change symbolically using delta notation. It now says that this symbol, delta P, the change in P, like the change in a population, is going to represent the absolute change in population from one time period to the next. Then change of P divided by the original or starting population is going to represent the relative change during that time period. So take what you already know about absolute change and relative change. Let's add in, manipulate a little bit with a new set of symbols and go to question 2. So looking at question 2, in the fall of 2017, Lone Star College Kingwood had an enrollment of 12,950 students. That was in 2017. The enrollment during the fall of 2010 was 10,000 students. Calculate the change in the population. My brain remembers it better as ending number minus beginning number. We saw earlier in the paragraph for this lesson, it said that the absolute change is the difference between a final value and an initial value. So our final enrollment that we're talking about in this problem is 12,950. The initial enrollment being, 10,000, let's start that one over. 10,879. So our delta P, our change in the population, it ended at 12,950. Let's subtract where we began in this particular problem at 10,879, and our delta P is 2,071. And then depending on what's going on in your class or your homework and what you need to label this as, it's always good to tell yourself what you just calculated. And these are the amount of students that there is a growth from 2010 to 2017. But then let's look at it as a relative change to calculate delta P over P. And we are going to reuse the number we just got, that delta P, those 2,071 students. And we're going to divide it by the initial population beginning whatever we're talking about in this particular problem. And we're talking about 10,879 students. We are asked to leave this as a percentage and specifically to round it to the nearest tenth of a percent. And actually on my calculator, 2071 is still there. So I'm going to divide it by 10,879 and then multiply it by 100 and then round it to the nearest tenth of a percent. And what I'm seeing is 19 point. Well, the 3 behind the 0 is not going to make this go up any more than what it is, so 19.0%. Additional parts of this lesson to help you with the lesson in your 1332 class includes understanding parts of a formula. Sometimes formulas can look pretty scary. We want to make them very calm and familiar and okay in this 0232 class. Formulas do often contain multiple pieces, but they each have their own meaning and they're not really scary. They're really very doable. And during the in-class activity, you're going to look at the following formula and it's related to logistic growth. But if you'll notice, this is what we were just working on. It's a relative change, a change in the population divided by the original population. And then the other pieces may not look familiar, but K usually stands for some constant in mathematics. Then we have a parentheses and a 1, a minus. Hey, P is probably population. And then L, well, even if we may not know what the L is, we can at least notice that there is one and it's part of the parentheses. So just note that the left side of the equation is the expression for relative change. We noted it. We saw that that is what we were just working with. And now let's look a bit more deeply at that part inside the parentheses, the 1 minus P over L. So just a reminder, we're going to be playing around with looking at what's going on or what are some things that we can relate to the parentheses part of the formula we just looked at. So let's talk about this. Part A, if you have, by the way, if you haven't already hit pause and worked on this question by yourself, please hit pause and come back and join me later. If you have $3,000 in a savings account and you spend $750, what percentage of your savings account, of this $3,000, what percentage of it have you spent? Well, I spent $750. And if I spent $750 of the $3,000, I'm going to divide it, and then I'm going to multiply times 100 and say that I have spent 25% of my savings account. That has been spent. If you spend 25% of the money in your savings account, what percentage of the account remains? Well, if I spent 25%, 75% remains. So what is a mathematical expression that describes how you calculated the remaining savings? How did my brain think, oh, it's 75%? Well, my whole account has 100% of the money. I spent 25% of the money, and I'm down to 75% of the money. What whole number equals 100%? Well, 1. or 1.0 or whatever, but 1. So rewrite your expression from part C using whole numbers and decimals. Well, instead of 100%, let me write it as a 1. And instead of a 25%, let me write it as a 0.25. And that's a minus, and it equals 0.75. So my expression of taking a whole minus a part is starting to look very familiar to what we had in the other formula, or in the formula, where it's a whole amount minus, because that's what I even did to get the 25%. I had 1 minus, and remember my 25% was a fraction. It was what I spent over what was in the account. So let's keep digging deeper on this formula. So delving a little bit more into this formula before you see it in class, it says now let's look at this expression and think of P as a part and L as a whole. In the savings example from question 3, what does P represent and what does L represent? Well, P, it's the money that I spent. It's the part of the savings, that part that I spent. And L, well, that was the whole amount in my savings. Continue with the savings account example. So then what did 1 minus the P over L end up representing? Well, early in the example, I took my $300, or I'm sorry, let me go back and look at the numbers. It was $750 out of the $3,000. And once I had that fraction, then I could subtract it from a whole, as it was a decimal or a percentage. I could do it from 100%. And so what does this whole thing going to represent? Well, if this is what I've spent, and this is what was in the account in its entirety, then the whole thing represents that 75% we had a while ago. So it represents what is left in the savings account. So think on this for a moment, make all the pieces and parts make sense, and then we're done with this lesson, 11B. Go look at your syllabus to see if there are more lessons to do before this week's deadline, and get them done and uploaded before Friday at midnight. And if not, upload this one and go do work on some other subject.